So now that we've explained factor methods and completion stage methods in the context of the ImageStreamGang example using completable futures, we're going to focus on the final piece of the puzzle, which is the arbitrary-arity methods portion. So let's talk about how those get applied. So this is the part where collect is used. As you can see, collect will return a single completable future to a stream of completable futures which are associated with images that are in the midst of being asynchronously downloaded, filtered, and stored. So that's kind of what we're going to be doing here. And as I mentioned before, nothing starts running till collect is hit. At that point, all the wheels start turning in motion, and we get back this single completable future, which we then use to wait for all the other asynchronous processing to complete. So it's an extremely lazy and very dynamic operation here. OK, after, of course, everything's completed, then we display them. We're going to use a really interesting variant of a collector called stream-of-futures collector, which is a revision to the earlier futures collector I showed you previously, which I should have called list-of-futures collector. And this is going to wrap the all-of method, which is that arbitrary-arity method that's available in completable futures. So you can take a look at the code. We'll look through the code here in a second. Once that single completable future completes, then we kind of wrap everything up. And what we're going to do here is for the stream of results that we have coming out of this, we're going to get rid of everything that's empty and then go ahead and log the result. There's a couple different ways to do this. This is the way to do it with Java 9. Java 9 has some enhancements to optional to add this cool flat map feature that can be used with optional : stream to automatically strip out empty elements from a stream of optionals, which is pretty cool. If you don't have Java 9, and if you're using Android, sadly, you don't have Java 9 yet, here is the Java 8 way of doing the same thing. It's a bit more verbose. What you do is you filter only optionals that are present in the stream, and then you get the result. So you can see this is a little bit more verbose than this cool Java 9 feature. But sadly, Java 9 is not supported on Android yet, although hopefully at some point it will be. And then we wait for everything to finish by using join. All right, so let's talk about the stream of futures collector. So this is a wrapper, like a candy wrapper. It wraps the all-of method. And what it does is stream of futures collector converts a stream of completable futures to elements of type T into a single completable future that will trigger when all the other completable futures in that stream complete. So you'll end up basically getting, as a result of this, a stream of elements of type T. And it's basically a non-concurrent collector, so it can be used for both parallel and sequential streams. We don't use parallel streams here. We use sequential streams. It's a little bit overkill to use parallel streams in completable futures. Stream of futures collector implements the collector interface, and that, of course, accumulates everything into this mutable result container. So it's a nice, very powerful wrapper for what would otherwise be really complicated code. This should look familiar to you. It's just got one slight deviation from what we had seen before. Stream of futures collector implements collector, so it's a custom collector. The type of element that it accumulates will be a completable future to type T. The internal mutable result container will be a list of completable futures of type T. So that's what the accumulator method will return. And then the result type of doing the collecting will be a completable future to a stream of T. This is a little different from what we had before. The previous example, the earlier futures collector, had a list of T here, not a stream of T. So that's the main way it differs. So before we had a list of T, now we have a stream of T. I could have used list of T, but then I would have had to have converted the result into a stream for subsequent processing. Here's what the supplier method provides. It's a factory method that returns a supplier that the Java 8 streams collector framework uses to create a new mutable array list container. So this doesn't make a new array list. This returns a supplier that the framework uses to make the new array list. Likewise, accumulator is also a factory method. It returns a by consumer that the streams collector framework uses to add a new completable future into the mutable array list container, which was created by the supplier returned from this factory method. Here's combiner. It returns a binary operator that can be used to merge two partial array lists together. This is only relevant if you're using parallel streams, which we're not. And then finisher is the one that does the cool stuff. So this is a factory method that returns a function that's used by the streams collector framework to transform the accumulator, the array list, which is the accumulator type, into the completable future result type. So that's what this function will do. And here's the function. So as we talked about before, the function works by converting the list of completable futures into an array of completable futures, and then passing that array of completable futures to completable future all of, which is the arbitrary-arity method. If you recall what all of does, all of returns a single completable future that will be triggered when all the other completable futures in this array finish doing their computation. That single completable future is then processed by a completion stage method called thenApply, and this will get called when that single completable future completes, which means all the other completable futures are completed. And at that point, what we're going to do is we're going to go ahead and convert the list of futures, this guy here, into a stream of futures, and then we're going to join each of those things. So what this will return, and this call will never block because we'll never call join until this completable future completes, which means that all these things have finished. So join will never block, but we just need it to convert the completable future to T to a T. And what this returns, which is a little different from the previous example, this returns a future, completable future, to a stream of elements of type T. So I should probably highlight this thing. So what we get back is a completable future to a stream of elements of type T. Characteristics just sets what we've got. It's a factory method. And here's the static factory method that makes a new stream of futures collector. So given all that stuff, here's how this gets applied. When the collect method terminal operation is hit, the toFuture factory method is called, which is this guy right here. And as you can see, that makes a new stream of futures collector. That stream of futures collector is used to take the stream of optional images and then create a single completable future, and it sets all the wheels in motion. Everything is running at that point. This is really where all the fun starts. And that single completable future is then used to finish the processing once we're all done at the end. Okay, so that's the final part of this discussion. I think you'll discover looking through these examples will help you with portions of assignment number 4, because a lot of the same features are used, although the flow of control is obviously a little different for your assignment number 4. Although you'll discover with your assignment number 4 that you're also combining completable futures and streams in various interesting ways.